Hello, my name is Falk Amelung and I'm a professor of geophysics at the University of Miami's Rosenstiel School of Marine, Atmospheric and Earth Sciences. The purpose of this video is to introduce a research project on satellite monitoring of buildings in South Florida, for which we are seeking funding from the state of Florida. The tragic collapse of the Champlain Tower south in Surfside motivated us to investigate whether the interferometric synthetic aperture radar technique can be used to monitor coastal buildings. Let me explain the technique. This is a satellite image from the European Sentinel-1 satellite. Now we are zooming into the white box into Surfside and Bal Harbour. We combine 50 of those images to obtain a very precise ground displacement map. It shows subsidence hotspots indicated by blue colors. The main subsidence area centers on the new Surf Club Hotel, which was built a few years ago. This suggests that subsidence could be an after effect of construction. The data show 2 to 3 centimeters of subsidence until 2008 when subsidence levels out. There's also 2 to 3 millimeter differential subsidence between 2 pixels, but luckily that is not very much. Another structure that shows subsidence is the Oceana Residences, which also was built in 2016. There's 3 centimeters of subsidence and 1 to 2 centimeters of differential settlement. This is also not much, but could lead to cracks if it continues for years. So what is going on? The weight of a building alone can cause subsidence. This is not a problem if a building settles as a whole and expected by geotechnical engineers. However, our data show the settlement continues for years. This is not expected. Also not that not only the new building subsides, but also nearby structures. This differential settlement can lead to cracks. The big question is what causes this unexpected long-term subsidence. In most of northern Miami-Dade, there is a layer of sandy sediments on top of porous limestone. The limestone has voids and interbedded sand layers. Is subsidence due to the closure of voids, or subsidence caused by the motion of interbedded sand? Sand is a granular material and can exhibit strange behavior, such as year-long slow motion after vibrations have stopped. Our satellite technique can also be used to monitor the impacts of the mine blasting activities in the limestone mines in western Miami-Dade. This video zooms into one of the mine blasting locations. Just 3 miles away in Miramar, our data show several blue dots on some of the homes. These are high spatial resolution data which are difficult to obtain. These dots indicate sudden subsidence at some time during the period covered. We don't see similar sudden subsidence anywhere else and think it represents displacement caused by vibrations from the mine blasting. We request funding for 2 things. First, for high-resolution imagery as shown here. The satellite needs to be tasked to acquire imagery. Second, for graduate students and postdoctoral researchers so that we can further develop and test our technique and publish peer-reviewed articles. For example, we see several blue dots in downtown Miami, but are not yet sure about the location of these dots. We also see subsidence of the Broward Courthouse in Fort Lauderdale, of which the upper floors were temporarily closed because of cracks in structural beams. Again, we need to do additional analysis to be certain about the location of those dots. Several large cities have started to investigate the use of this technique for monitoring of structures, as shown here for Barcelona and Spain. We hope to do this for South Florida. In addition, our vision is a multidisciplinary research project using remote sensing, seismology, and geotechnical laboratory experiments to better understand the response of the ground to vibrations from construction and mine blasting. Thank you for your attention.